Hi everyone, this is Miss Cobb and I will be showing today's lesson in ELA. Our story today will be Galaxies by Gail Gibbons. You all are familiar with her because she was the same author that wrote Hurricanes. And we will be learning about could there be life on other planets? Why or why not? That is our essential question for the week. So before I show the book, before I read the book, we're going to watch a video show that. So there will be some screen sharing. So hold on just a moment. And I'm going to start sharing the video. So just hold tight. The first video that we're going to watch will be on the solar system.
The Milky Way galaxy, home to our solar system. It's believed our solar system formed at least 4.5 billion years ago when a huge cloud of dust and gas collapsed into a dense mass. That mass began to spin and flatten into a disk. The center grew hotter and hotter until finally a new star, our sun, was born. Leftover dust and gases continued to whirl around the sun and over millions of years formed the planets and moons that make up our solar system. The sun is at the center. Its gravity binds the solar system together. It accounts for 99% of the solar system's mass. The closest planet to the sun is Mercury, a relatively small planet known for its extremes of temperatures, above 800 degrees Fahrenheit during the day and minus 300 or so degrees at night. Next is Venus, the near twin of the Earth in size, mass, and density. Its atmosphere is mostly carbon dioxide, a greenhouse gas that traps the sun's heat and raises the surface temperature to nearly 900 degrees Fahrenheit. Clouds of sulfuric acid swirl above Venus's rocky surface. The third planet is Earth, an active planet that's constantly changing. More than 70% of its surface is covered by water. Earth teems with life, something that so far has been found nowhere else. Just beyond Earth lies Mars, a barren planet with striking geographic features, including red soil, canyons 4 times deeper than the Grand Canyon, and polar ice. Between Mars and the next planet is the asteroid belt, millions of rocky fragments, most no more than a mile across. The fifth planet from the sun is far and away the largest, Jupiter, a gaseous giant big enough to hold more than 1,300 Earths. Its great red spot alone, a huge hurricane-like storm, is twice as wide as Earth. Saturn, the second largest planet, is next, famous for its massive rings of ice and ice-covered particles. Seventh from the sun is Uranus, which is unique because it rotates on its side. It too has rings and at least 27 moons. Neptune, the 8th planet, is perhaps the windiest place in the solar system, with gusts over 1,200 miles per hour. Neptune marks the end of the planets, but not the end of the solar system. Farther on is Pluto, a dwarf planet. At its greatest distance, Pluto orbits more than 4.5 billion miles from the sun. As vast and diverse as our solar system is, it's but one in a galaxy of billions of stars, in a universe comprised of billions of galaxies.
All right, that was a video on the solar system. Again, remember, earlier this year we did a lesson on the solar system, talking about the different planets. And this video was just used as a review to kind of jog your memory about the solar system. Now, the next video we are going to see will be about the sun. So hold tight. And what I'm going to have to do is I'll just pull up the video through YouTube because it is a YouTube video and it did not save, so I'll just have to type it in, so bear with me. And the video that you all are about to see is a video that we've seen before with previous lessons, with Crash Course.
1, 2, 3, go! Faster, faster! Happy Friday!
Oops. There we go.
Pop quiz. What's the closest star to Earth? It's called Sol.
Never heard of it, you say?
Sure you have. Sol is the sun. Ancient Romans, who once worshipped the sun, called it Sol, and it's become the kind of official scientific name for the sun. It's where the term solar system comes from. Sol, or the sun, is the star at the center of our 8-planet solar system that provides us with energy. Without the sun, Earth would be a dark, frozen world with no life. But how does the sun's energy get to us? Well, first, let's talk about what the sun is. It's a 5-billion-year-old big ball of super hot gas. The hottest part of the sun is its core, or center, which is about 15 million degrees Celsius. Whoa. Its surface is not quite as hot, but it's still almost 5,600 degrees Celsius, which is pretty toasty if you ask me. And as for its size, the sun is so huge, you can line up over 100 Earths along the face of it, and more than 1 million Earths could fit inside it. But the sun's size isn't what makes it seem so big and bright to us on Earth. It's because it's so close to us that it seems way, 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 way bigger and brighter than other stars. So, you know that the sun is hot and bright, and that heat and light are both kinds of energy that we get from the sun. Let's take a look at a model to see how the sun's energy gets from good old Sol to our planet. Here's the sun. Energy is created in its super hot 15 million degree core. That energy then travels outward from the core to the surface of the sun. But this journey from the center of the sun to its surface can take over 100,000 years to complete. But once the energy deep inside the sun finally gets to the surface, it travels as light and heat all the way to Earth. In fact, it only takes about 8 minutes for light to travel approximately 150 million kilometers through space to Earth over here. That's not such a long time. So to sum up, energy is created in the sun's core. It travels very slowly to the sun's surface before it takes a super speedy trip to Earth in the form of light and heat. And you and I can see and feel that energy as sunlight. Without the heat and light we get from the sun, Earth would be just a frozen ball floating around in space, which would be a total bummer. So, thanks, Sol. You're a real star.
All right, so that was a video about the sun, and as you already know, the sun is a star, and it is a star that is in the middle of our solar system. So now we are going to read our story for today, which is Galaxies by Gail Gibbons. So we're going to wait for it to load. And this book is a nonfiction book, which means it's giving us information about something that is true. A star is made up of burning gases that give off heat and light. On a clear, dark night, many stars light up the sky. A milky band of light glows from one end of the night sky to the other. And again, remember, the star is a what? Well, not a star, a sun. I just gave the answer away. The sun is a star. The milky band of light is called the Milky Way. It is made up of so many stars that they blur together when viewed from planet Earth. And this little dot right here is the Milky Way. This is a text feature, and remember, friends, this text feature is called a caption, and it reads as follows. Gravity is an invisible force that pulls objects that have mass together. So again, our planet has gravity, and it has the just right amount of gravity to where we are able to stay on the planet where we don't float. And the gravitational pull is not so large that we are just on the ground, basically crawling because of the pull. We are able to get up and walk freely. So that's why I say Earth has the just right conditions with gravitational pull. The Milky Way is part of the Milky Way galaxy. In the galaxy's vast areas of dark space, there are clouds of gases, stars, and dust that exist around a nucleus or central core. All of these things have substance to them called mass. They are held together by gravity. Planet Earth and the other planets that orbit around our sun make up our solar system. Our solar system is a small part of the Milky Way galaxy. And we have some more captions. A solar system includes anything that orbits around a star. Our sun is a star. A planet is a large body that orbits around a star. So we have our sun, which is a star. And then here's our planet Earth, which of course is the third planet away from the sun. Orbit. Orbit means to travel around another body. So our planet, along with the other planets, orbit around the sun, meaning we travel around the sun. In ancient times, people looked up at the night sky in wonder. They tried to understand what a star was and explain what the Milky Band that was spread across the night sky. So even in ancient times, there were people who were studying the night sky, trying to figure out what was in the sky and what was making that Milky Band. Ancient Greeks called it the river of milk and believed it was created by one of their gods when he was a baby. Ancient civilizations tried creating maps of what they saw in the night sky. Today, we call the study of stars and other celestial bodies astronomy. So those who work in NASA specifically, but also they can work for other places. Scientists who study the planets and everything and stars, they're called astronomers. Now we're going into the different types of telescopes. The first type is the refracting telescope. In 1608, a Dutch eyeglass maker named Hans Lippershey put a lens at each end of a tube. He called the tube a spyglass because it made distant objects seem closer. 1 year later, the Italian astronomer Galileo Galilei created stronger lenses, making objects in the sky appear even closer. Later, his invention was called the refracting telescope. This is Hans Lippershey, and this is Galileo Galilei. Telescopes are used to view distant objects. We have the objective lens, which bends light from stars into the telescope body, and the ocular lens, which magnifies. With this kind of telescope, the observer looks directly at the stars and other objects. So with their galaxies chart, you're going to be writing one thing about the refracting telescope and also about the next type of telescope, which is the reflecting telescope. In 1666, an Englishman named Isaac Newton invented the reflecting telescope. He placed two mirrors inside the telescope that bounced light back to a magnifying lens. His telescope was smaller, but stronger than others had been. And these are the different parts of the reflecting telescope. You have a concave mirror, magnifying lens, and a flat mirror that reflects an image to a lens. A reflecting telescope reflects an image by using two mirrors to view stars and other objects. And then again, this is a picture of Isaac Newton. At first, astronomers believed the Milky Way galaxy was the entire universe. Over time, telescopes were made larger and their lenses stronger. The stars and other objects in the night sky became clearer. Many new discoveries could be made, such as those by the Herschel siblings, Carolyn and Sir William, who observed previously unknown planets and comets. And we have the caption of the universe. The universe is of all of space and everything in it. Andromeda Galaxy. In the 1920s, an American astronomer named Edwin Hubble discovered that a large group of stars called Andromeda was not part of the Milky Way, but actually another galaxy. This was the first time scientists could confirm that there were more than one galaxy in the universe. Hubble and other astronomers discovered more and more galaxies. Soon it was determined that there were billions and billions of galaxies. The known universe was getting bigger and bigger. Distances in space are measured in light years. Because space is too enormous to measure in miles, the Milky Way galaxy is about 100,000 light years wide. Our solar system is only about 1.5 light years wide. A light year is the distance light travels in 1 year. About 186,000 miles, or 299,000 kilometers a second, are almost 6 trillion miles in 1 year. Now we're going into the 5 shapes of galaxies. And as you can see, we have the spiral, barred spiral galaxy, irregular galaxy, lenticular galaxy, and elliptical galaxy. Every star is a part of a galaxy. Some galaxies contain millions of stars and still others contain trillions. Scientists have discovered that galaxies come in different sizes. They also come in 5 different shapes, the best known being the spiral galaxy. Galaxies are held together by gravity. The first type, which is a spiral galaxy, the Milky Way galaxy is a spiral galaxy. Arms or stars, gases, and dust spiral out from its center. Our solar system is within the arm of Orion. So we have our solar system, and this is the arm of Orion, and that's where it is located. The Milky Way galaxy has more than 100 billion stars, our sun being one of them. Everything in the Milky Way orbits around its core. Many galaxies have a dense central part called the core, and this is the core. And this is a text feature called a diagram, which shows the different labels of different parts. If you look at the Milky Way sideways, it appears sort of flat with a bulge in its core. The Milky Way is in a cluster of 54 galaxies. A cluster is a group of galaxies. And again, this is the Milky Way's core, just if you look at it from the side. The next type is barred spiral galaxy. A barred spiral galaxy has a dense bar-shaped grouping of stars in its core. A spiral arm spins out from each end of the bar. So we have the bar-shaped center, and then we have the arms. NGC, which means New General Catalog, is a record that provides the identification and location of galaxies. So before they give official names, they label them in a catalog called the New General Catalog. So most galaxies that have not been officially named, because there's so many, they'll start off with NGC and a set of numbers. And this one is NGC 7479 galaxy. Elliptical galaxy. An elliptical galaxy is ball-shaped. The largest elliptical galaxies are believed to be made up of trillions of stars. So that is a much more than a million and definitely more than a billion. The NGC 4881 galaxy is an elliptical galaxy. Lenticular galaxy. A lenticular galaxy is shaped like a lens. Around the core of the galaxy are disks of stars and gases, giving it a lens-like or lenticular shape. And here's the core, and then the disk of stars and gases. The NGC 2787 galaxy is a lenticular galaxy. Irregular galaxy. This kind of galaxy doesn't have one kind of shape. Often irregular galaxies are small with lots of newly formed stars and bright gas clouds where new stars form. Some astronomers believe irregular galaxies form when two galaxies bump and merge into each other. The NGC 2366 galaxy is an irregular galaxy. There are two irregular galaxies that travel on the edge of the Milky Way galaxy called the Large Magellanic Galaxy and the Small Magellanic Galaxy. They are named for the Portuguese explorer Ferdinand Magellan. In 1519, he led the first expedition to sail around the world. The Small Magellanic Galaxy is about 210 light years away from the center of the Milky Way galaxy. The Large Magellanic Galaxy is about 179 light years away from the center of the Milky Way. And you will learn more about Ferdinand Magellan in middle school with social studies and in high school also with world history. Inside galaxies, some stars being born and others are growing older and dying. Astronomers classify stars by their colors. Blue stars, which is right here, and white stars are the hottest and youngest. Yellow stars and orange stars are the coolest and oldest. Our sun is a middle-aged yellow star, so it is in the middle. Our sun should heat Earth for another 5 billion years. Today, astronomers are able to discover and study even more galaxies. Observatories have huge reflecting telescopes that gather more light and allow observers to see deeper into the universe. Many observatories are built on the tops of mountains where the air is clear and there are no distracting city lights. Galaxies can give off different kinds of energy that help us discover even more about the universe. Some of these X-rays, gamma rays, ultraviolet radiation, and radio waves. Radio waves transmit sounds. Ground-based radio telescopes are use giant antennas to tune to radio waves coming from faraway stars and galaxies. More discoveries are made this way. A ray is a form in which energy is released from any object. A radio telescope's antenna is disc-shaped. Hubble Space Telescope. There are telescopes in space too. The largest, a reflecting telescope named after Edwin Hubble. Remember that famous scientist that we learned about in the earlier pages of this story? Well, that's him. There was a telescope named after him. It is about as big as a school bus. Because it orbits above Earth's atmosphere, it can see deep into the universe. The Hubble can see galaxies billions of light years away. And the atmosphere is a layer of air surrounding Earth. Unmanned space probes have been launched into deep space. These probes are loaded with cameras and other equipment for exploring. This is the Voyager 1. They transmit their discoveries back into astronomers on Earth. Remember, there was a probe that was also a rover that landed in Mars, and we watched videos on that last week. And also there's a probe that is outside of Jupiter's orbit called Juno, and we watched a video on that as well. So those are space probes. Currently, astronomers know there are more than 100 billion galaxies in the universe, with many left to be discovered. There are still more being formed, and even more yet to be formed. That is the end of the read aloud. I'm going to stop share, and I am going to switch over into the activity that you will be doing for ELA. So you have 2 activities to do. So let me go to share screen. Okay. I'm gonna share. So this activity you can do on a sheet of paper. You don't have to print it out if you don't have a printer, and you don't have to type it in if you don't feel comfortable in doing so. But we've learned about the different types of telescopes, which are reflecting and refracting. We learn about observatories and the radio telescope and the Hubble Space Telescope and space probes. So you are to do that. And if you would like, you can take pictures and send it to me via Class Dojo for feedback if you like. And then there's one more activity that you would do for today's lesson. It is just a small discussion. Okay, it is loading. And you would go to Galaxies discussion. So the question is, compare our galaxy Milky Way with another type of galaxy. And remember, our galaxy is a spiral galaxy. So you're going to compare our galaxy, which is a spiral galaxy, with another kind. You have 4 other types to compare it with. You write one thing that is alike, how it's alike, and one thing with how it is different. And also you can respond to another student. And as you can see, we already have some friends who have liked and have responded and replied. So these are the activities that you can do today for ELA. I hope you all are staying safe. I'm going to stop share, and I will be sharing more videos. This will be on YouTube, on my YouTube channel. I will share the link in Class Dojo and also have the link in Schoolology as well. And again, be safe and have a great rest of your day. Bye-bye.